Hi, everybody. It's Professor Monty again. Let's talk about conditional probabilities. So the probability of B given A. All right, I've got the definition here. The probability of B given A is the probability that event B happens, given that event A happens or will happen. Okay, so conditional probabilities, the probability something happens based on something else we already know. So let's look at an example here. I've got what we call a contingency table. So the number of students, these are actually the number of students that passed one of my statistics classes versus the ones that did not pass. So P for pass, N for not pass, M for male, F for female. So that's my contingency table. So let's look at the probability that somebody passed the class. So on all these, we're just using the F over N rule. I have a video regarding that as well. But the probability somebody passed is the number that passed, in this case 30, over the total number of people I can choose from, 43. Now, I already calculated this 0.698. But now let's look at a conditional probability. Now we're saying, well, what's the probability that they passed given more information? Oh, given that I know it was a male. So now I'm not looking at the grand total. I know it's a male, so I know it has to be in this column here. So I'm restricted to this column because the given information is given that it's a male. So now when I look, oh, 13 males passed out of 20 males. So this is still F over N, but in this case, it's 13 over 20. And on the calculator, I got 0.650. Notice it changed the probability having this additional information that I know is a male. There was a 0.698 or 69.8% chance that a random student selected in the class passed. But if I knew it was a male student, then the probability they passed was 0.650 or 65%. Let's look at the other way. What's the probability that they were a male student if it was somebody that passed? Well, now I know it's somebody that passed, so I know it's in this row here. Well, the probability that they were male was 13 out of the 30 people. So again, F over N, 13 out of 30. And when I calculated that, it came out to 0.433. So it depends which way we do these. Notice these are asking different questions. This one's the probability the person passed, knowing that they're male. This is the probability that they're male, knowing that they passed. Okay, and one quick note here. This is from another video I did on independence. Notice the probability of P was 0.698, but the probability of P given M, those were not the same. One was 0.698, the other was 0.650. Since those are not the same, it means P and M are not independent. Notice they both start with probability of P, but this one we have more information. Oh, it's not independent because if I know they're a male, it changes the probability of them passing. So this would tell me P and M are not independent. So that's a quick extra thing about that, how to tell independence given conditional probabilities. All right, work with these. It just takes some practice. You'll get it. Just keep trying, and I'll talk more later.